In the solvent, the hands of the clock and the segment labeled X form a triangle. As the time changes, the shape of the triangle changes, but the lengths of two of its sides do not change. In triangles that have two pairs of congruent sides, there is a relationship between the included angles and the third pair of sides. When you close a door, the angle between the door and the frame at the hinge gets smaller. The relationship between the measure of the hinge angle and the length of the opposite side is the basis for the side-angle-side inequality theorem, also known as the Hinge theorem. Theorem 513, the Hinge theorem, also known as the side-angle-side inequality theorem. It states, if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is opposite the larger included angle. So if, in this diagram, the measure of angle A is greater than the measure of angle X, then BC is greater than YZ. Problem 1. Using the Hinge theorem. And this one's multiple choice. Which of the following statements must be true? Well, A, statement that AS is less than YU. B, that SK is greater than YU. C, SK is less than YU. And D, AK equals YU. Well, segment SA is congruent to segment YO, and segment AK is congruent to segment OU. So the triangles have two pairs of congruent sides. The included angles, angle A and angle O, are not congruent. Since the measure of angle A is greater than the measure of angle O, SK is greater than YU by the Hinge theorem. The correct answer is B. Your turn. Part A. What inequality relates LN and OQ in the figure at the right? And Part B, a reasoning item. In triangle ABC, AB equals 3, BC equals 4, and CA equals 6. In triangle PQR, PQ equals 3, QR equals 5, and RP equals 6. How can you use indirect reasoning to explain why the measure of angle P is greater than the measure of angle A?